All right, so we're going to move into surface area problems, using surface area to solve some mathematical problems. And surface area is the sum of the areas of all faces of a 3D figure. So let's start with this prism over here. On the left is a rectangular prism, and hopefully you are familiar with rectangular prisms. This is a 6th grade topic, so it should be pretty easy. Erin is making a jewelry box of wood in the shape of a rectangular prism. The jewelry box will have the dimensions shown. She plans to spray paint the exterior of the box. How many square inches will she have to paint? So we're just going to find the area of each face and then add them together. So we'll start with the front. And we know that the front and the back faces are always going to be the same. So this dimension here is 6 by 12. So the height of our prism is 6. That's 72. And we have two faces that are 72 inches squared. We also have the left and the right faces, which we can see are 6 by 15 inches. So we have two of those faces, the one here on the right and over here on the left as well. And finally, we have the top and bottom faces. And those dimensions we see are 12 and 15. It's 180. We have two faces that are 180. And if we add all of that together, we get 684 inches squared. Pause here and try one. You have a box of uncooked spaghetti in a rectangular prism with a length of 9, width of 2, and height of 1.5 inches. What is the surface area? I would suggest drawing if you can. And the way we do that is you can draw a smaller rectangle up here in the front, one about the same size back here to the right, and then just connect the corresponding vertices. And we'll label a length of 9, a width of 2, and a height of 1.5. So go ahead and find the surface area of that box. Okay, so we'll start with the front face. Remember, the front and the back are going to be the same. So that's 2 by 1.5, which is 3. And we have two faces that are going to have that area. Remember, there are 3 pairs of faces that are the same when we're looking at surface area of a rectangular prism. We have the left and the right faces, which share a dimension of 9 and 1.5. So 9 times 1.5 is 13.5. And then finally, we have the top and bottom faces, which have a dimension of 9 and 2. and 18. And if we add those together, we get a total surface area of 69 inches squared. We can also look at triangular prisms. So the same idea, we always want to start with the base. So I'm going to highlight this in red, and I want to find just the area of the triangular base. And on a triangular prism, keep in mind there are going to be 2 triangular bases. So if I just look at the triangle, I see that there's a base of 16 and a height of 6 centimeters. It's going to be 1/2 times base times height, 16 times 6. Half of 16 is 8, times 6 is 48. And we have 2 faces that are 48 centimeters squared. We have this face right here on the front, which has dimensions of 16 and 12. So 16 times 12. And that gives us 192. Now we're not going to double this one because if we look, there's only this one face. There's only one face here that has that area or those dimensions of 16 and 12. And then back here we have two faces that actually have the same dimensions, 10 and 12. 10 times 12 is 120. And remember, two faces that add up to that are both 120. And so if we add all of that up together, we get a total area of 528 centimeters squared. Now there's a formula that you can use to find surface area of prisms, and I just want to introduce it to you. It is surface area is 2 times B plus P times H, where B is the area of the base, P is the perimeter of the base, and H is the height of the prism. Now, if you feel really comfortable with surface area, I suggest using the formula. It's a really good and fast way to find surface area. If you struggle with surface area, then I would recommend that you use the traditional way of finding the area of each face and adding all those together. But if we want to use the formula, just so you can see how that works, 2B plus PH, we're going to start with 2 times the area of the base, because there are 2 bases on this figure. We already figured out that the area of the base of this figure is 48, so 2 times 48, and if you look, we have 2 48s up here, plus the perimeter of the base, so 16, this is 10, and this is 10, which make 36, times the height, which is 12, and we can simplify that expression. 2 times 48 is 96, plus 36 times 12, 432, and if we add those, we get 528 centimeters squared. Use the method that works for you. The equation does take some practice because it is new. Pause here and try 2. All right, so keep in mind that even though this prism is on its side, this triangle is still the base. So we'll use the perpendicular base and height to find the area of it. Not this 5. That 5 is the slant height. We don't need the 5 to find the area of this triangular base. So 1/2 of 3 times 4, because the height there is 4. 1/2 of 12 is 6, and remember there are 2 triangular faces that have the same area here. Next we'll look at this face, and we see easily that the dimensions are 4 by 4. We'll look at what the figure is sitting on, and we can see those dimensions are 3 and 4. Which is 12. And finally, we see back here, it's a little hard to see, but we can see that dimension here is 5 by parallel to this line here is 4 over here. So 5 times 4 is 20. And so our total surface area is 60 centimeters squared. We're going to move to square pyramids and triangular pyramids. So again, I'll show you both ways. I'll show you how to find the area with each face, and then I'll show you the formula as well. So again, I always like to start with the base, and I think you should too. So it's a square base, which means all sides here are going to be 5 inches. So 5 times 5 is 25. Keep in mind that there's only one base on a pyramid. Next, we will look at our lateral faces. And we know the defining area of a triangle is 1/2 base times height. So 1/2 of 5 times 8, which is 20. Now, because it's a square pyramid, that means we have 4 sides that are going to be the exact same. You could also just multiply that 20 by 4. So 25 plus 20 times 4 is 80. 25 plus 80 gives us 105 inches squared. Now again, there is a formula that you can use. Surface area equals base, the area of the base, plus 1/2 perimeter times slant height. And when we talk about slant height, it's literally the slanted height of a pyramid, the one that goes from the apex, that point at the top, to the base. So just to show you how to use that formula, B plus 1/2 PL, it's a cursive L. Capital B is your area of the base, which we already figured out 5 times 5 is 25, plus 1/2 times our perimeter is 5, 5, 5, and 5 to make 20. And your slant height is 8. So 25 plus 1/2 of 20 times 8 is 160. Half of that is 80. Gives us 105 inches squared. So again, you can use whatever method works for you. Pause here, and I want you to try the triangular pyramid, but realize that you have a triangular base, and it is equilateral, which means all sides are going to add up, or be 10 in this case. Okay, so let's start by finding the area of this triangle. We see if we just look at this triangle, we have a base of 10 and a height of 8.7. So 1/2 of 10 times 8.7 is half of 87, which is 43.5. And let's look at our lateral sides, our lateral faces. 1/2 of 10 times 14, or half of 140 is 70. And we have 3 sides that are 70 here, because it is a triangular pyramid. So if we add up 43.5 and our 3 70s, you should have gotten 253.5 meters squared. Moving on to composite shapes. Composite shapes, just like composite 2D figures, you can find the area of composite solids by adding up the visible sides. So you have to subtract or disregard anything you don't see. Okay, this might be a little difficult to visualize, so if you're having trouble with this, come talk to me about it, and I'll be happy to go over it with you if during tutoring or if there's any extra time in class. But let's start with example 4. We have a cube up here at the top, and if you think about it, a cube has 6 sides, but we can't see this bottom side here, this side here. We can't see that because it's in between those 2 shapes. So we're going to disregard that. So if you think about the cube, you can only see 5 shapes here, 5 faces, 5 square faces. Now each one of them has a dimension of 2.5 by 2.5. So the area of one face is 6.25. And because I can only see 5 faces of that cube, I'll multiply that 6.25 by 5, and that gives me 31.25. And that's the visible surface area, the area that I can see. So now I want to look at the rectangular prism. And I'm going to use the formula to help me find the area of this, just to make things a little quicker. 2b plus ph. So look at your rectangular prism. Here's the base. And the area of that base is 99, because 11 times 9 is 99. So 2 times 99 plus your perimeter. 11 plus 9 plus 11 over here and 9 over here gives me 40. times the height of the prism, which is 7. So we'll simplify that. 198 plus 280 gives me 478. But realize there is a side here that we can't see. So we do have to subtract the area of that square that we can't see. So I'll subtract 6.25 from this. And get 471.75. And then I'll just add it to my 31.25. And get a total surface area of 503 meters squared. Let's do U try 4 together. Let's start by looking at the rectangular prism first. Keep in mind, normally we can see 6 sides, but we can't see this right here because it's in between those two shapes. So we're just going to ignore that. So we're going to find the area of 5 sides or 5 faces of our rectangular prism. So if we start here, our base, 18 times 22, that gives us 396. Moving forward, we have these 2 faces right here. And back here, remember those are going to be the same, the front and the back. 20 times 18 gives us 360. We have 2 of those. And we also have here 20 by 22, which is 440. And 2 sides that are 440. So if we add up the areas of the rectangular prism part, that'll give us 1,996. Next, we want to go through and we want to find the surface area of the triangular prism. And normally they have 5 faces, but we can only see 4. The 2 triangles and the 2 rectangular faces. So starting with the triangular bases, I see I have a base length here of 18 and a height of 12. So 1/2 of 18 times 12 is 108. And I have 2 of those. And finally, we have 2 rectangular faces that are the same. And its dimensions are 22 by 15. And you can see the 15's right here. It means it's going to carry all the way around. And that's 330. Remember, there are 2 sides that are 330. If I add all that up, that comes to 876. And if we add our 2 composite figures together, we get a total surface area of 2,872 meters squared. The last thing I want to show you is surface area of cylinders. Now, with cylinders, they're more of an 8th grade and geometry topic, but you will see them on Think Through Math, so I want to show them to you just so you have an idea of how to approach those. The formula is 2 pi r h plus 2 pi r squared. So take 2 times 3.14, which is pi. Your radius is 6 on here. And your height of the figure is 9. We multiply that out. That's going to give us 339.12. And we want to add that to 2 pi r squared, So that's 2 areas of the base. 2 times 3.14 times 6 squared, which is 36. And that's 226.08. And if we add those together, we get 565.2 feet squared. So it was a really long video, but we did spend a lot of time in class working on this. But if you have any other questions, please feel free to come talk to me about them.